We've had several lessons in our unit on rational functions, on graphing rational functions. We started off with ones with vertical and horizontal asymptotes and no holes, and then we talked about they might have holes. Then we added in our slant asymptotes. But what we're going to do today is look at the graph, and from this graph, hopefully be able to write the equation. I think this is a little bit easier than sketching the graph yourself. The information that we've been finding to make our graph is going to help us on this graph find the information we need to write the equation. So here's what I'm talking about. If I had an equation and I wanted to find the x-intercepts, we said the shortcut was to set the top equal to 0. So the top of whatever our equation, the numerator, is going to give us our x-intercepts. When we want to find vertical asymptotes, we use the bottom or the denominator in our equation. So whatever's in the denominator is going to be where our vertical asymptote. For our holes, this is the top and the bottom. So because what happened there in our equation, if we had a hole, then the factor divided out. It canceled out. And so if there's something that divides out or canceled out, then that would have been a hole. So if we have a hole in our graph, we're going to have to put that in the top and the bottom of our equation. Now, the horizontal asymptotes have to do with the exponents on the top and the bottom. The slant, again, has to do with the top and the bottom. The y-intercepts we found by putting 0 in for x. So these three things over here, these are the things that are going to probably help us the most in writing our equation. So let's go ahead and fill out all of our chart, and then hopefully you'll see what I'm talking about here. So our x-intercept looks like it's at -2. -2, 0. Our y-intercept on this one looks like it's at 0, 2. Vertical asymptote right through here, so it looks like it's about -1. Our horizontal asymptote also looks like it's at about a +1. Since we had a horizontal, there would not be a slant. And this graph does not have any holes either. If we did, they would list it as an open circle. All right, so here's what we're going to do. Since -2 is an x-intercept, then as a factor, this would be written as x plus 2. So we're going to put an x plus 2 in the numerator of our equation. In the bottom of our equation, we got a vertical asymptote of -1, so as a factor, it would have been x plus 1. Does everybody see what I'm talking about here? If I were to set this equal to 0, I would get -2. My x-intercept, set this equal to 0, I would get -1, my vertical asymptote. If I had a hole, then I would put it in the numerator and the denominator. So this is pretty much my function. Y equals this equation. Now the only thing that I need to do at this point is check to see if all of this other information is going to work. If not, then I may have to make just a few small changes. But here's what I'm talking about. For my y-intercept, if I were to put 0 in here for x, would I get 2? Yes, I would. That works. For the horizontal asymptote to be 1, these have to be the same exponents, which they are, and we have to use the lead coefficients in front. 1 divided by 1 would be 1. So this is the equation of our function.